So we were in the middle of the domain name server and then we took a break. So this figure should bring the context back and this figure as well. Now let's see, what does the DNS server store? The DNS servers maintain a database of what are called resource records. These resource records are a 4-tuple. They consist of a name, value, type, and a time to live. The relation between name and value is dictated by the type. I'm only going to cover 4 different types. There are more, but these 4 are the most important ones. So when this type is set equal to A, the name refers to a host name and the value refers to an IP address. So here is an example. So this is a type A record where it is telling that this particular host name maps into this particular IP address. This is a type A mapping and the time to live for this particular mapping is 17 seconds. So this TTL field specifies how long this record can be cached at the local DNS server. Type NS refers to the name server. In this case, the name refers to the domain and this value is the host name of the authoritative name server for this particular domain. For example, this is a type NS record. So this is the domain name and this is the authoritative DNS server that resolves host names that are part of this particular domain. The type CNAME helps in host aliasing, where in this case the name refers to the host name and the value is the canonical name. So for example, when you advertise www.facebook.com, internally this maps to this particular host name. This entry is recorded as a CNAME entry. And then there is the mail server aliasing, which is achieved through this type MX. In this case, the name is a domain name and the value is the canonical name of the mail server. So for example, this is the domain and this is the mail server that corresponds to this particular domain. So here are a few rules. What type of entry should an authoritative name server for a given host always hold? Well, for a given host, if this is the authoritative name server, this should always contain the type A record for that particular host. That is this host name and the IP address corresponding to it, this type A record, this particular authoritative name server should always contain it. If it is a non-authoritative server, for example a TLD server, what type of records should that particular server contain? Well, it should contain both the type NS record as well as the type A record of the domain's authoritative server. For example, the .com TLD will carry both a type NS, which specifies what the name server for this particular domain is, and in addition to this, it also needs to carry a type A record that maps this particular name server's host name to an IP address. So here is the DNS message format. I'm not going to get into a lot of details for this. The points to note are that the DNS runs over the UDP protocol and uses port 53. Why do you think that uses UDP and not TCP? Well, you're just exchanging one message to the DNS server, and for this one message you don't want an overhead of the three-way handshake as well as the connection teardown. UDP has lot less overhead. So as far as this message format is concerned, there is an identifier that is used to identify the request reply. There are a bunch of flags, for example, that identify whether this is a query or a reply, whether this reply is coming from an authoritative source, or whether recursion is desired, or whether it is available. What does recursion mean is that when the local DNS server is contacting the root DNS server in the example, the root DNS server will in turn contact the .com TLD server, and this .com TLD server in turn will contact the Facebook.com authoritative server and get the IP address and pass it back, and finally the root will pass it back to the local DNS server. What we have seen in the earlier example was what is called an iterative query, whereas this is a recursive query. What is done in practice is an iterative query, but DNS does provide this option of recursive query, which is not often supported. by some of the DNS servers. Then you specify how many questions are there as part of this message, how many answers are there as part of the replies, how many authoritative resource records are there, how many additional resource records are there. As I said, I don't want to get into too many details. This is just to show you the structure of a DNS message. The fields of relevance are the questions and the answers, which we will see in action in a demo. Another important thing we should know is how do these records get inside the DNS server in the first place. So let me explain it through an example. Suppose you had this brilliant idea and have established a company and you want others to visit your company's website. Let's say you name your company bi.com. So one of the first things you will do is you will try to register this particular domain name with a registrar. There are a few such registrars which charge money for this registration. So what the registrar does is it checks to see that this domain is free. If it is free, it is going to assign it to you. Now, as part of this registration, you're also going to specify the registrar the name and IP address of your primary and secondary authoritative DNS servers. So what this means is, let's say this is your company. Within your company, you are allocating two hosts who are going to be the primary and secondary DNS servers. Let me call this a.dns.bi.com and this as b.dns.bi.com. And you're going to tell the registers these names along with the IP addresses corresponding to these hosts. Now what the registrar does is it ensures that these four entries, that is the NS name and the IP address, again this other name and the IP address, are entered into the .com TLD. Now apart from these authoritative DNS servers, your company also has a web server and a mail server. Let me call the web server by this same name. This is the host name corresponding to this, and the mail server as mx.bi.com. By the way, capital or small letters don't make any difference. Now what you do is within this authoritative DNS servers, you are going to maintain a type A record that corresponds to your web server, where you basically note down that this corresponds to the IP address. Let me call it IP1 of this particular host, and this is a type A entry. Similarly, you will also have an entry which has something like this, which corresponds to the type MX, where it says this is the mail server for this particular domain, and you will also have an entry that will say that this is the IP address 2. Let me call this IP2, and this is a type A address. Now if some host outside in the internet were to type this URL as part of its web browser, its local DNS server is, let's say, going to contact the .com server directly because it's cached within. This .com server has entries corresponding to these particular DNS servers, so it will get back saying, I don't know, why don't you contact a.dns.bi.com, and this is the IP address corresponding to this. Now as a consequence of this, this local DNS server is going to contact the a.dns.bi.com and ask it what is the IP address corresponding to this. So this DNS server will look at its entry, it matches this, so it will give back the IP1, and then the user here is going to establish a TCP connection with this IP1 as the destination. So that's how DNS works. Be sure to check out a demo using the dig command uploaded on the website to see DNS in action. So to summarize, DNS is a very core internet functionality that is implemented at the application layer. It provides not only the host name to IP address translation, it also provides host aliasing, mail server aliasing, as well as load balancing. The way it implements this service is via a hierarchical distributed architecture for scalability reasons. So there are different levels of DNS servers. There are root servers, top level domain servers, authoritative servers, as well as a local DNS server. As we have seen, these servers help resolve queries. They maintain this database consisting of resource records, which are retrieved by an end user to establish communication with other hosts in the internet.